problem would be solved. But then in 1889, a French mathematician called Henri Poincaré discovered there was no way of predicting the orbits. In some cases, no matter how similar the paths were at the start, if there was any difference at all, eventually one would fly off on a different and totally unexpected and unpredictable path. Prediction, Poincaré lamented, becomes impossible.
He saw something behaving in a way that he didn't expect, and he realized it was to do with the initial conditions and what we now call sensitivity to initial conditions. And that's what was unexpected, that if you just tweaked something a very little bit, you could get a huge difference in outcomes. That was where he actually discovered what we now call mathematical chaos.
Poincaré had glimpsed a profound truth about the planets and their orbits. What disturbed him was that he realized this unpredictable behavior might be present throughout nature. He realized a small disturbance, no more than the flapping of a butterfly's wings, might be enough to create a storm where none was predicted. This was a very different world to Newton's.
And I think the interesting thing is the fact that he was so himself, even Poincaré, the sort of greatest mathematician around at the time, was still immersed in that view of thinking that things would all work out nicely, that everything in the end behaved properly. And he was horrified when he discovered the way these solutions worked out, and you could get this what we now call chaotic behavior. It was quite shocking to him.
Poincaré's discovery struck at the root of a view of the world which neither he nor his contemporaries were yet willing to give up.
The world in which he was living and moving was still very much one that was embedded in that Laplacian view. This very strange behavior that he discovered was sort of glossed over by the commentators.
People were just not ready to hear that their world was not as orderly as they'd always believed. Then in 1914, in Sarajevo, a tiny disturbance did push the whole world system from its course. This was the tiny disturbance that started the uncontrollable storm. In hindsight, we can see how appallingly prescient Poincaré's discovery had been. But at the time, the rest of the world was just not ready to listen. They were still determined to believe that they lived in a Newtonian world, where even the complexities of human affairs could be predicted, and the war would be over by Christmas. When World War I broke out, they all wheeled out their artillery, confident reality could be made to follow their plans. After all, the same mathematics which predicted the orbits of the planets also governed the firing of artillery. The mathematics of ballistics told them exactly where the shells would land.
Of course, at the beginning of the 20th century, ballistics was essentially firing at a stationary object. And you might have to fire over something, so you might not be able to see what you were firing at. So the mathematicians had sort of sorted it out. They had range tables and so on.
The magic of science, this predictability of things through mathematics. Science is not just proving theorems, it's to give us some power over nature about what happens, predicting an eclipse, this kind of power. Building steam engines is also power, and science was built in part about that.
The tragedy of the war was that no matter what carnage unfolded, they believed there was not only a science of ballistics, but a science of war, a way of predicting how many men per mile of front would win the objective. They thought if they understood the science of war, they could control its outcome. they could simply overpower the chaos. In the end, they weren't fighting each other. Both sides were fighting the chaos of reality. In the end, the chaos defeated them all, and 10 million men died. Poincaré's notion that a small, unnoticed disturbance could eventually cause an unstoppable storm was the first discovery to tell us the world is less predictable and controllable than we'd like it to be. One of the mathematical roots of modern anxiety. The second was uncovered in Russia by Alexander Lyapunov. He was studying the transition from stability to instability in fluids, but doing so during the great upheavals of World War I and the Russian Revolution. Lyapunov was studying the way a fluid or gas becomes turbulent. It was one of the most intractable problems in all of physics, and he was trying to put a number on that transition from order to chaos. He was trying to understand how systems seem to maintain their order, almost resisting change, but then reach a critical point at which they seem to flip suddenly from smooth to turbulent, from order to chaos. What we now call tipping points.
This move away from the idea that the world is ultimately predictable to one where it's unpredictable is mostly associated, at least in the climate and environmental world, with this idea of a tipping point. So this idea that you push the system and it goes, basically, how far it moves, how far it changes.
Professor Peter Cox is one of the UK's top climate change experts and an advisor to the government.
In that case, you imagine a system, say you're rolling a ball up a hill. You know, if you roll the ball up a hill here and you let it go, it's going to go back down this way. But say there's a peak on the hill. You roll it up so far at this point, it can go either way. And then, of course, if you're at the top of a hill, you can push it an infinitesimal amount and it'll be off. And there's no relationship between the ultimate displacement and how hard you push it. So it's essentially an unstable system.
Lyapunov's work had begun to put a number on this moment of instability. The moment when the ball at the top of the hill is pushed over, when the orderly plume of smoke suddenly becomes turbulent.
Most people, when you ask them what is dangerous, is falling off a cliff, right? I mean, and that's the equivalent of a tipping point, right? It's where the system changes and you can't go back.
But while Lyapunov was still trying to understand instability, his life was approaching its own tipping point, when the chaos of the Russian Revolution and World War I overwhelmed him personally. Tens of thousands of war wounded had been pouring back from the front and brought with them an epidemic of tuberculosis. When his wife became infected, Lyapunov tried desperately to save her. But on October the 31st, 1917, she died in his arms. Hours later, the same day, he put a bullet through his brain. Poincaré had discovered that our world might not be as predictable and controllable as we had thought. Lyapunov's work had put a number on the moment of transition from order to chaos and opened the door to the modern idea of the tipping point. Between them, they had discovered what could have been the beginnings of a new and profound understanding of the world. That chaos is a part of the system, not just its breakdown. But Lyapunov was dead. Poincaré never took his work any further. And the rest of us, we wanted only to believe that chaos and unpredictability were just a nightmare from which we could wake. We stood at the place where a clearer understanding branched off, but we did not take it.